So like polytheism is a belief in many gods, polygamy, many spouses, polygon, many sides. Yeah. Okay. A polynomial is made up of a monomial. It could just be one term, or it could be the sum of many monomials, which is what you'll see. It should only have whole number exponents, meaning they shouldn't be negative, they shouldn't be variables, and it should be a continuous function. Okay, so we'll be graphing polynomials here in the next couple days. It's going to be fun. Okay, we have names for them. If it's one term, it is a monomial. So I will highlight that prefix if you've got highlighters. Mono. So like monogamy. You're with one person. Okay, a monomial could look like this, where it could just be a number. So like 3. It could look like this, where it's just a variable, x. Or it'd be a combination of those two things. It could be something like this, where it actually has two different variables, 4, x, y. So that's an example of something that's one term. Everything is side by side. Even though you have 4 and x and y, they're all smooshed together. That's one term. Any guesses on what two terms would be called? Bi, like a bicycle. Yeah. And if you're like, oh, this seems familiar, it should, because it's from Algebra 1. Like so many things in this class. Yeah, a binomial. Oh, I guess I put that in the wrong box. Hold on. It goes up there. I know. I'm so sorry. I was like, where's my box for my example? There it is. Okay, so an example of a binomial would be like 5x plus 7. 5x is a term and 7 is a term, and there are two of them. They are split. Terms are split with addition or subtraction. How about 3? Mono, bi, tri. Like a tricycle. So my son got a pedal bike for Christmas. He is 3.5, and he can do it, folks, which is awesome. My daughter learned at 4, but he's been doing the balance bike, and he can do it. It's pretty fun. Okay, so an example of a trinomial would be like x squared minus 5. I already did 5x. How about 4x? 4x plus 1. So this is a trinomial because you have x squared, you have negative 4x, and 1. Those are 3 terms. And if you have 4 or more, we give up and we just call it, just kidding, we don't give up. We just don't have a special name for it. So it's polynomial. Remember, what does poly mean? Many. So 4 or more, we're just like, there's a lot. So we say polynomial. Oh, I don't know. What could we do if I have like, use Miss Waller's example because it's better than mine. Oh, this one's a little crazy. 3x squared y plus 4x minus y minus 8. Woo! So it could have a combination of two different variables. Okay, we are going to write things in standard form when we have polynomials. You need to make sure that the highest degree goes first. Then you will descend, meaning go down. So typically you'll see this with like x to the 4th, x to the 3rd, x squared, x constant. And also it needs to be alphabetical. This is what's a little bit weird and kind of confusing, and even I'm not amazing at it, so we'll all get better together. So for example, if you have 2x squared, that has to come before something like 5y squared, because x comes before y. You are looking at these variables. Whatever your highest exponent is will tell you what your degree is, unless it's a monomial, and then things get weird. So if my highest exponent is 0, we call that constant. An example of a polynomial that's a constant would be something like 5. So I'm putting an example in parentheses for you. Next step up, if it's an exponent of 1, highest of 1, it's linear. So something like x, or x to the 1st. Degree of 2 is called quadratic, and that's when it's squared. Any guesses? Do you remember what it's called when it's to the third power? Cubic. Nice. Cubic. X to the third, so it's cubed. Okay, and there are 4 quarters in a dollar, so when it's degree of 4, it is called quartic. So that would be something that's x to the 4th. And then lastly, kind of like quintuplets, which is 5 babies born at one time. No, thank you. This is quintic. X to the 5th. Okay? So you're looking at your highest exponent. If it is weird and it's a combination of x's and y's, then, so for monomial only, this is the confusing part about our day. If you have something like this, 2x to the squared y to the third, you need to look at both of these because you couldn't just tell me that this is cubic because obviously it's not cubic. You have x squared and y to the third. That's weird. So you actually have to add these up. So the degree here is actually 5 because you add the exponents on a monomial only. So you would tell me that the degree of that one is 5. That does not happen if it's just like x to the 4th. You would just tell me it's a degree of 4. Fun. So the square root is a problem because the square root actually causes it to have an exponent that's a fraction. You need this to be something normal, like x squared or x to the third. You want it to be an x to a power or a variable to a power. And this is not, this actually rewrites as 2x to the 1/2. So the problem here, no, because you have a square root. No, thank you. We're not doing square root functions. We are doing polynomials. It makes it become a fraction. Okay, the next one looks like it would be a no, but it's actually a yes because you could rewrite it like this. What exponent does that x have? You don't see it, but what is it? There's 1x. Anything weird there? You're looking at the exponents. X to the first. 2/3 is fine. It's a coefficient. So this is yes because your exponent is okay. That's all you care about. What about number 3? No. Who's the problem? -5 right here. Okay, so this one is no because your exponent is negative. And when we're dealing with polynomials, we want them all to be positive. The exponents. The other terms don't matter. I'm highlighting the problem. Okay, can you talk at your table about number 4? It's kind of weird. I don't see any fractions. I don't see really any negatives. So is it yes or no? Are all your exponents whole numbers? No, they're x's. Weird. No, this is not going to work. So this is a problem, and this is a problem. Your exponents cannot be variables. They have to be whole numbers. Only. That's the only option. Whole numbers are 0. Okay, what about number 5? Your exponents are 4, 2, and 0. Yeah, that's fine. Did you know that? Do you remember what this will become? Anything to the 0 power is 1, actually. Strange. So it's actually going to become 8x to the 4th plus x squared plus 1. So yeah, this is fine. Because your exponents are okay. Okay, and then the last one. So we have a fraction again. Where is the x? Top or bottom? Bottom. What do you think? Yes or no? No. Okay, that's because this would make it become a negative. Remember when you move variables to the other side, it changes the exponent. So why? Because the x is on the bottom. And it would cause it to have a negative exponent. Up here, a number 2, the x is on the top. And that's why it ends up being okay. All right? So x has to be on top. Exponents are positive. They are not fractions. They are not variables. Basically, you're looking for things to be normal, okay? The coefficients can be anything. They can be decimals, fractions, whatever, negatives. It's the exponents that you got to watch out for. And where is the x? So we're going to look at a couple examples. We're going to name some stuff. Okay, so look at the first one here, number 7. What is my highest exponent? X to the third. So that term has to go first. And you have to take the whole thing, the negative 5, x to the third. Take the sign in front of it. Okay, and then we're trying to stair step down or descend. So the one that comes next is squared, negative 8x squared. And the last one is x. So you can see how it goes power of 3, power of 2, power of 1. Okay, I will try and color code for your learning. The degree, highlighting that in blue. The degree is the highest exponent, so my degree is 3. And then I will underline here, there are 1, 2, 3 terms. Okay, because my degree is 3, I call it close. That's the number of terms. It's confusing because they're both 3s. Okay, I have a poster here on the wall you can reference. Degrees are the fancy names, and the nomial names are the number of terms. So my degree is 3. It's cubic. The number of terms is 3. That's the try. It's kind of like how many wheels do you have on your bike? You've got 3 wheels, so it's a trinomial. Okay? So trying to color code so you can see the difference. Okay. Not helping us that they're the same number. Let's look at number 9, and we'll come back to number 8, so make sure you skip ahead. Number 9 is actually already in standard form because it's squared, and then the power of 1 comes second. So that one is done. Okay, highest exponent is 2. So that is, or my degree on that first term is 2, so 2. And again, my number of terms, 2. And that's annoying because they match again, but it's fine. I need to get you one that's not the same so we can learn a little bit better. My stylus is done. So thank you. Okay, 2. So the degree, look at the poster on the wall if you need to, so you don't have to flip back. Highest exponent of 2? Quadratic. That's the first name. The last name is the number of terms. It has 2 terms, so it's a binomial. Okay. Let's look at number 11. I'm just kind of, no, never mind. We'll come back to number 8. I'm all over the place. Okay, what's our highest exponent on number 8? 4. So that one goes first, 10x to the 4th. Okay, and we are going to decrease the x's here. You can see you have a y as well. That's a little strange. It's fine. So squared, negative 7x squared, plus 4xy, because we're still just focusing on the x's, and then minus 10. Okay, your highest exponent is 4. So that gives it a first name. The first name for the degree, if it's 4, you can look at my poster on the wall, is quartic. There's 4 quarters in a dollar. And annoyingly, again, it has the same number of terms, right? Yeah. So number of terms is 1, 2, 3, 4. When you have 4 or more, we call it many, polynomial. Okay, can you please try the last 2 at your table? Talk about it. And I will write them on the board. When you don't see an exponent, what is it? 1. Yeah. So this is a monomial. So you're giving it first and last name. And it's linear. Okay, you do need to do some rearranging in the last one. Make sure you take the signs with it. Your highest exponent here. Oh, they are not the same, finally. Okay. Number of terms. Okay, so this last one, here's your name for it, if I could spell it right. And the first name should be based on the degree, so that would be, I don't know if it's quintic or quintic. What do you guys think? Quintic? Quintic? I don't know. Okay,